Hi everyone. Today we're back with a literary principle question. Okay, let's see. The concentration versus time graph is shown above for the exothermic reaction. And the reaction is nitrogen gas react with hydrogen gas to form ammonia. Now, what change has occurred that makes, okay, so this is what, till here we had our equilibrium and something must had happened in time t because the concentration is changing, right? So that means something disturbed our equilibrium. We want to know what disturbed it. Okay, so first of all, let's just write our equation here. We have N2 gas plus 3H2 gas and we have 2 ammonia gas. Yeah. Now, we can see that this is an exothermic reaction. So let's just add our delta H on the product side as well, okay? Because exothermic means it's released the energy, yeah? So, okay, now we know that, let's just analyze the graph here. What happened to our H2? It's actually increased. Okay, so H2 is actually increased. N2 is also increased. So we can see that the one on the reactant side is actually increasing, while the NH3, which is on the product side, is decreasing, right? That means our reaction is actually going on the reverse way. Okay, where it's actually moving, we can now apply the options to see which one is correct. Okay, now let's see one by one. Oh no. Okay, now let's see one by one. So when we remove NH3, right? When we remove this part, what's gonna happen? When we decrease this, the reaction is going to wants to increase it. Okay, it always do the opposite way. So if you decrease, it wants to increase, and if you increase, it wants to decrease. Okay, so because you are decreasing it, that means the reaction wants to increase it by moving to the right, right? But we want the reaction to move to the left, so that's not it. So A is wrong. Okay. Now, let's see the second option. The volume was decreased. So if you watched the previous video, you would know that volume, okay, pressure, when we increase pressure, the reaction moves to the lower mole. And when you decrease pressure, it moves to the higher mole. Okay, but it also relate with the volume. What do I mean by that? If you actually decrease the volume, so you decrease the volume, it's actually going to move to the lower mole. Okay, move to the lower mole, because if you really think about it, when you decrease the volume, you are actually also increasing the pressure, so the effect's going to be the same, right? Decreasing volume is kind of like increasing the pressure. So you can see that the mole, the movement is going to go to the lower mole. So the same thing happened here. So if you increase the volume, it's going to go to the higher mole. So we know that among these two, on the reactant side, we have 4 moles. We have 1 plus 3, yeah? And on the product side, we only have 2. So because we want it to move, okay, if we decrease our volume, it's going to move to the lower mole. And which one is our lower mole? On the product side, because we only have 2 versus 4 on the reactant side. So it's actually going to move to the right. So that's not it, because we want something moves to the left. And if we decrease our temperature, what's going to happen? If we decrease our temperature, we kind of decreasing the enthalpy here, which is on the product side right now. So if we decrease the delta H, right, it wants to move towards it, because if we decrease, they want to increase it. So this is also moving to the right. So that's not it. Now, if we increase the volume, increasing volume means it moves to the higher mole, and the reactant side, which is 1 plus 3, which is 4, is the higher mole, and it's going to move to that side. So the correct answer is D. So this question has everything about the Letellier principle. So make sure you are 100% sure about your Letellier before trying to attempt this kind of question. Thank you. Bye-bye.